Hello class, today we're going to be talking about simplifying radicals. It is a concept that's usually taught in Algebra 1, but it's been my experience that not all Algebra 1 teachers get an opportunity to teach it, and it's important because we're going to be using it in geometry. And so that's why this video is serving to introduce to you a topic that you should have experience with, but you probably don't. You actually do know what radicals are. Anything with a square root is considered a radical. So the radical part is something that can be rewritten as a square root of something. And the radicand is the part that's underneath the square root. Now we're going to actually be dealing with square roots in geometry, but when you get to Algebra 2, they're going to be cube roots and quadruple roots and 10th roots and things of that sort. So we're just going to be talking about mainly the square root. Okay? And so we're going to simplify it. Now, there are easy radicals to simplify and there are more challenging radicals to simplify. So let's talk about what it means to simplify. To simplify a radical, we mean to look for perfect square factors of the radicand so that we can rewrite the radical so that the radicand is as small as possible. So if we have a radicand that's a perfect square, life is easy because the square root of a perfect square is a whole number. So if I were to take the square roots of any of these perfect squares, I would get a whole number. Square root of 36 is actually equal to 6. But what if I don't have a perfect square as a radicand? What if I have, for example, the square root of 40? Well, the square root of 40 is not going to be a whole number. In fact, it's going to be an irrational number which has no end. And that irrational number is going to be between the whole numbers of 6 and 7, but it's actually not equal to 6 nor 7, and it's going to be a decimal approximation because the irrational part will continue on forever and ever. It's going to be 6 point something 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 something. But we can rewrite it so that we don't have to lose the accuracy, but we can rewrite it to a simpler place. So let's do that. So in order to simplify radicals, we have to look for perfect square factors of the radicand. So the radicand is 40. So if I want to look for perfect square factors, you may want to start by using a factor tree. And there's several different ways to factor 40. We can do 8 times 5. We can do 2 times 20. We can do 10 times 4. There's a lot of different ones we can do, but we want to do something in such a way that we do have a perfect square factor. And the only ones of these factors that are perfect square factors is this one, because we have a perfect square factor of 4. And so that's the one we're going to choose, because 8, 5, 2, and 20 are not part of our perfect square list. So if we choose, since we've chosen this one, then we can rewrite this radical in terms of this factor pair. Okay. And a property of radicals is that we can break them up into separate things. Okay. Why is that of any importance? The importance is, even though 10 is not a perfect square factor, 4 is, which means I can evaluate the radical of 4 and let it be a whole number. So the whole number will actually be 2. So this square root of 4 is really 2. So another way that I can use to rewrite this radical so that it is simpler than the original is to rewrite it as the product of 2 times the leftover radicand, which is the radicand that cannot be simplified. And if you were to plug each of these expressions into a calculator, you would get the exact same decimal approximation for each of these. But which one is the simplest one? The simplest one is this one because it has no perfect square factors in the radican. Something with a radical and a multiplier outside of it. All right, that's it. So let's try another one. Let's come up with the perfect square. Let's try and simplify the square root of 100. Well, for those of you who don't know that 100 is a perfect square, you would go through the process of trying to find perfect square factors. And we can go through and say, well, 100 is the same thing as 25 times 4. 100 is the same thing as 10 times 10. And vice versa. 100 is the same thing as 20 times 5. And we can go on for another factor pair. But I want to take a look at this one because this one has perfect square factors. So to do that, I could rewrite this as the square root of 25 times 4. But because of the properties of square roots where I can break them up, that becomes the square root of 25 times the square root of 4. Well, some of you may be saying, wow, well, the square root of 25 is 5. You're absolutely correct. And the square root of 4 is 2. You're absolutely correct. So together, this is a product of 5 times 2, which we know is equal to 10. So if it's a perfect square, then it will end up being a whole number when we take the square root of it. But if it's not a perfect square, then when we simplify the radican, we're going to end up with something like we did in slide